Hello everyone, we are back with our second sorting algorithm that we're going to be learning in this course, and that is insertion sort. As we did with bubble sort, before we go into writing code for this, we'll do some background on how the sort works and step through it manually. The basic idea of the insertion sort algorithm is as follows. We iterate through the list, checking whether elements are in sorted order. That is basically comparing side-by-side elements, kind of like what we were doing with bubble sort. Where the difference comes in is what we do in the event of an element not being in sorted order. If this is the case, rather than, as with bubble sort, propagating the larger element towards the end of the list, we will propagate the smaller element backwards towards the spot that it belongs in the sort, giving the effect of more or less inserting the smaller element in the correct place in the list. So to get a better idea of this, let's take this small example list that I have here and step through the insertion sort algorithm manually. So because elements are propagated backwards, we actually start with the second element in insertion sort. So we start off with 5 and we compare it to the one before. And so since 5 is greater than 3, this little chunk is in sorted order already, so we don't need to do anything. We move on to the next one, 8. We compare 8 with 5. 8 is also greater than 5, so we now know that this whole section is in sorted order. We now go on to the next element, 4. So 4 is less than 8, so it's on the wrong side now and will need to be adjusted. So what we do is we are going to shift these elements past the 4 until the 4 has been inserted into the correct position. So we take the 8 and we swap its position with 4. And after we've done that, 4 will be here. We then compare it with 5, and it's still smaller than 5, so we then swap 5 with 4, and so on until we reach the correct spot. So after 2 swaps, 4 will be in the correct spot right here. So then the list will look like this. It'll be 3, 4, 5, 8, 2. You can see how basically what we did is we shifted these to the right of the 4, effectively inserting 4 in the correct spot in the list. Now we do the same thing with the final element, 2. So 2 is smaller than all of these. So what we're going to need to do is go through sequentially backwards and check, is 2 smaller than, rather, is 2 greater than or equal to 8? No. Greater than equal to 5? No. Greater than equal to 4? No. And 3? No. So we know that we have to shift 2 all the way back to the beginning. So then this is going to look like this. And there we go. We have a list in sorted order. So this is how you carry out the insertion sort algorithm. And in the next video, we're going to implement this in Python. All right. In this video, we are going to implement the insertion sort algorithm that we stepped through manually in the last video. So per usual, I'm going to start with my function definition, and it will take in, since it is a sorting algorithm, just the collection that we are sorting. And we can go ahead and jump right into the main loop that we will use to iterate through the list. So we will do for I in range. And remember that insertion sort always starts on the second element. So rather than 0, we will start this at 1, and we will go until the length of the array. Okay, so now that we're inside of our loop, we need to now keep track, first of all, of the current element that is going to be compared and inserted into the sorted part of the list. So we're going to store that in a variable that I will call current element. And that will be assigned to whatever the value is at the index I in our list. Now comes the fun part, where we can actually start shifting elements to the right to move our current element to the correct position in the list. So we're going to initialize another sort of pointer variable that will help us achieve this. So I will call this variable j. So I will say j is equal to I minus 1. So basically, we've got two sort of pointers going here now. We've got I at our current index. So let's say we're going to be shifting this 4. In this case, I would be 3, as it's at index 3. And then j, we would initialize it to 2. So j would be pointing to this element right here. And so now what we're going to need to do is iterate backwards through the list by decrementing j, progressively shifting these elements to the right until we find the correct spot to insert the 4. So we will create a nested loop here that will accomplish this backtracking. So I will create a while loop where the condition we're running is j is greater than or equal to 0. So basically that means that we have not reached the end of the list, or rather the beginning of the list. And the current element must be less than whatever the value at j is currently. Because if the current element is equal to or less than the value that is currently at the j pointer, we know that we have found the correct spot to insert this element. As for instance, if we were to go up here and run through it on this list again, we would start off with I at 4, or not start off, but the first element we're going to be shifting will be this 4. So I would be 4, j would be 8. We would shift backwards until j is at 3, pointing at 3. And then only then would the current element 4 be less than whatever the element at index j is. And that is exactly where we would want to insert that 4. So now we know while this loop is going, we're going to need to be shifting elements. And we will basically accomplish this by duplicating the element into the current spot that we're at. This might seem somewhat counterintuitive, but once we reach the end of this iteration, there will be no duplicate elements left because all of them will have been overwritten by the next elements. And then the final instance will be overwritten by whatever the element we're inserting is. So what we're going to do here is we're going to say whatever the element at j plus 1 is. So in this case, if j is 8, then j plus 1 would be this element right here. So we're just going to set that equal to whatever it is at j. So this will essentially duplicate that j element. And then we're going to decrement j. So j minus equals 1. And it will just continue doing this until we have found the place we need to insert. When we found that, our while loop will break out or stop running. And now we can finally do the thing we've been waiting for, to insert the current element into the correct position in the list. So to do that, we're just going to take our j plus 1 and set that equal to the current element. And then after all of this, we can return our collection. And that is actually all there is to it to insertion sort. So before we go ahead and run some tests and timings to compare the two sorting algorithms that we've learned so far, let's just run some tests to make sure that this insertion sort is correct. So I'm going to create, well, so yeah, I can use this thing that I wrote up here. So I don't actually need that. I will just say sorted list equals whatever the result of insertion sort on L is right here. So we're hoping to get this value out of it. And I will print the results here. Okay, and there we go. We can see that we successfully sorted our list with insertion sort.